Hello, in this video, we're going to be discussing passive components. Now, we've already discussed circuits, but we've actually got to talk about the components themselves, which is why I'm starting with passive components. Along with their physical properties, I'll also be talking a little bit more in depth about resistors, capacitors, and inductors, as well as mentioning some of the other passive components, and also show how they're presented in every circuit and Fallstat circuit simulator. So, what is a passive component? Well, it's any electric component that stores, dissipates, or transfers electrical energy, but it otherwise doesn't amplify it or modify it. It also doesn't require any external power source aside from that is already in the circuit. Resistors, capacitors, and inductors, kind of known as the big three, they'll be the passive components that you'll most commonly use and use a lot of them. And we'll be covering them each in a more in depth video. But aside from these, there are some other passive components, transformers, switches, fuses, passive filters, passive attenuators, balloons, and I don't mean the ones you fill up with air, crystals, resonators, and transmission lines. And again, we may have videos that cover these ones in depth down the road. Resistors are passive components that resist the flow of electricity in a circuit. Although resistance is basically present in everything to some extent, even the conductive wires, um, but they all reduce voltage and current. A resistor just means that you're doing it intentionally and in a much larger amount. Capacitors, they store electrical energy is an electric charge, sort of like a battery, but not technically a battery. But capacitance could exist in other components, and that may be desired or undesired depending on the component. Inductors do the same thing, but they generate magnetic fields. But induction can be present in other components as well. And again, it could also be desired or undesired. Now, we've also mentioned diodes, and they can be regarded as either active or passive, depending on the circumstance, the model, etc. But for my videos, I'm going to be grouping them with active components, and we'll definitely be covering both in a later video. Power sources and ground, they're really their own category. They're not neither passive or active because they're not components on the circuit. They're the beginning and the end. All right. So in addition to the big three, there's also other passive components. There's switches. These are components that basically make a new circuit pathway or they break one. They usually do both, actually. Transformers basically use the principle of induction to transform voltage from one value to another because they transfer this through magnetic fields. Um, Fuses are meant to break a circuit, various circumstances, such as circuit protection. Some are one and done, others are resettable. Then you have passive filters. These are filters built for passive components. We're going to really cover this in depth in later videos. A balloon, which is short for balanced, unbalanced, and it's meant to bridge two types of signals together. I don't know if I'm actually ever going to cover this unless I get into radio signals. Um, Passive attenuator, which is an attenuator that's made from passive components, and attenuation is the lowering of the strength of a signal. Um, Crystal, which is a crystal, usually quartz, it vibrates at a specific frequency when electricity is applied to it, and then it returns a specific voltage signal back. This is important for computer clocks. A resonator is kind of similar to a crystal. It simply responds strongly to a signal and then it kind of rejects others. A transmission line is a passive structure that carries electricity, usually at high voltages and frequencies, from one point to another, and it's what makes electrical grids possible. Now, there's a number of very important physical properties of circuits I need to mention. We've talked about resistance, which is the opposite to electrical flow, which dissipates as heat. Then there's capacitance, which I've also mentioned for electricity charge. And then I've also mentioned inductance, which is the ability to store electricity and magnetic charge. There are a number of other qualities that are going to come up in videos. Impedance, at least in terms of a circuit that combines resistance and reactance into not only the resistance in an AC circuit, but how this affects delays and shifts. We'll talk about this more in videos on AC circuits. Reactance, that's the other half of impedance, which is how much electricity goes back into the circuit instead of being stored or dissipated. Again, something for circuit videos. And then we've got resonance, which is when inductive and capacitive devices they reach a certain balance, and this can cause large oscillations or energy transfers. Again, AC circuit videos. And conductance, that's just the inverse of resistance, and that's basically how easy it is for something to conduct electricity. This will come up from time to time as its own property instead of just saying the inverse of resistance. Admittance is the inverse of impedance, and that's basically how easily current flows in an AC circuit, and it's made up of conductance and subsistence. And then lastly, we have subsistence, which is how easily stored motion energy in an AC circuit lets current flow. As I said, a number of these concepts will show up more in AC circuits. However, a couple of them will also show up in circuits. All right, now going back to the big three, I've already mentioned resistors and their passive components. They're measured in ohms. Usually that's designated by the Greek symbol omega. But in a pinch, you can use a lowercase c, and I guarantee you there are professionals who will disagree with me on that. While resistance can exist in other components, resistors intentionally introduce a set value of resistance to a circuit. Then we move on to capacitors. They're measured in farads, designated by a capital F. But when we'll be using capacitors, we'll probably be using ones that are nanofarads, microfarads, or kilofarads. And then we have inductors. We'll mostly be talking about those in AC circuits. They're measured in henries. Yeah, you heard that correctly. But most of our inductors will probably be in the millihenry range. Inductors have some other properties that we'll discuss when we get to them in a future video. All right, now components have schematic symbols. These are how they look in every circuit. First, you've got the resistor. Now, keep in mind, depending on the standard you use, that's either ICE, also known as ANSI, and IEEE. It's either a squiggly line or it's a small box or small rectangle, and sometimes the value can be on top of the rectangle. With a capacitor, you'll notice there's two lines, and that's to indicate that in a standard capacitor, there's two basically electric plates, or plates, whatever, and the charge is actually stored between them. As far as I know, that's the same symbol regardless of the standard, at least between standards. And then lastly, we have the inductor. It's a little coil symbol, and the reason for that is coil is the older name for inductor. It's actually still used for inductors in some cases. And then here we have the same symbols in Elstead, which they're basically the same symbols, although they may be a bit more stretched out or small in certain parts of. So just to wrap things up here, a passive component is any electrical component that stores, transfers, or dissipates electricity, but it doesn't otherwise modify or amplify it. It also doesn't need a external power source, just the power from the initial signal to function. Resistors, capacitors, and inductors are the big three, but there's plenty of others. Diodes be treated as active or passive in certain cases, but in my videos, I'll be discussing them active components. Some of the other passive components include switches, transformers, passive filters, passive attenuators, crystals, resonators, and transmission. We'll have videos about some of them. Resistance, capacitance, and inductions are important physical properties that we'll be constantly mentioning, but there's a number of others, such as impedance, reactance, resonance, conductance, mittance, and substance. I still can't say that word without stumbling. Every circuit, Volstat, and basically every other circuit simulator has symbols for each of these, and they can be represented as either ICE or also known as ANSI for the American way, and then IEEE or the European way. Well, until next time, have a good one.